draw scatter diagrams, which you guys have done before in Algebra 2. You have drawn lines of best fit. I'm going to focus, I'm going to show you how to do some of the stuff by hand, but we are going to have an emphasis on the technology on this piece, an emphasis on using the calculator. But we should know how to do the stuff by hand. So if I put this up here, data is based on a study for drilling rock. The researchers want to determine whether the time it takes to dry drill a distance of 5 feet in rock increases with the depth at which the drilling begins. So the depth at which the drilling begins is the explanatory variable. We haven't seen these terms in a while. Explanatory variable, that's your x. And the time it takes to drill is your response variable. So explanatory is the x, response is your y. Draw a scatter diagram. You guys know how to do these by hand, right? It's just plotting points, like ordered pairs. Let's talk about how to do it on the calculator. So we are going to enter our x's into list 1 and our y's into list 2. So go to stat, edit. If anything's there, clear it out. Remember, clear, not delete. And then type your x's in your L1 and your y's in your L2. L2, yep. Then go into your stat plot, so that's your second y equals. We have gone into this plot a lot. We need to go into plot 1. And this time we will make sure you turn it on. We want a scatter diagram. So that is just the first one on your list. So stat plot, I went into plot 1, turned it on, and then the very first one is your scatter plot. Then you should be able to zoom 9, which is just your zoom stat, and we should get our beautiful scatter plot.
That's really gross.
What if I asked you to describe this relation? You've done it in Algebra 2. Did everybody get to that point?
No.
I'm not doing Algebra 2 stuff.
Anybody else?
No.
Yes, I taught.
Yeah, because that was when she went on maternity leave and Miss Burns had was that your threshold? She was I think it's probably I've been having this for a long years so far. Yeah. Yeah, and Miss Kelly.
Was it? Oof, that was in 8th grade. That's so loud. That's so long ago.
Yeah, Algebra 2 is not
that wall.
Yeah, it's like right next door. You remember me walking in on the first day?
Yeah, when it's 7 hour 2.
Yeah.
We had
Yeah.
while she was still on. Whereas in number 2, got a C minus on our mine. Still had a B plus in the class though, so. If I had a B plus in my class too, though.
After that class, it was lunch, and they wouldn't let us just go.
That's what I did in class.
So we had to go back to those little ticket attendants and then off lunch.
It is a positive. Why?
Oh, it's going up. Puff, puff, positive.
Puff, puff, positive. Would you call it a strong or weak, do you think? Weak because they're more spread out. We talk, you know, the closer together they are, the stronger the relationship. Okay, so this is like a weak positive relationship. Now I have on the next slide just some different relationships. These would be linear relationships. You know, this would be a positive linear and a negative linear. These two, it's not a linear relationship. There is a relationship there, but it's not linear. This one would be more like quadratic. This would be more like a cubic relationship. So we focus on linear. There are relationships that are just not linear. Now this one, there's really not a whole lot of relations. So it is possible that we don't see any patterns, and we might call that no relationship.
That's a really good straight line.
Well, it's kind of a horizontal line, a weak horizontal line there. Okay. Now, we are going to talk about the linear correlation coefficient. Okay. This is R. If you look at your lovely formula sheet, we are now in chapter 4. This is section 4.1. So the very first thing on chapter 4 is the correlation coefficient. And you have this beautiful formula there for you. These things represent stuff we've seen before. We know that sigma means the sum. X bar is the mean of the x. Y bar would be the mean of the y. S sub x, standard deviation for x, standard deviation for y. Now this formula, we are going to do one by hand. Most of the time we are going to use our calculator, but we will try one just to make sure we can calculate it. The correlation coefficient is going to tell us how strong the relationship is. Now on the one we just worked out, we would get a positive value because it was a positive relationship. If it is a perfect linear relationship, you will get a 1 or a negative 1, whether it's positive or negative. You will always get values that range between those. The closer you are to 1 or negative 1, the stronger the relationship is. So this allows us to compare how good the linear relationship is in our problems. It is not resistant. Remember, resistant is like the median. If you add in another point, it doesn't change much. R is not resistant. If I throw in a weird point, it is going to drastically change my R value.
And your R is,
R is the correlation coefficient. So we're going to talk in a minute. It's that lovely formula. I put some pictures on here. This would be like the perfect case where R equals 1. Perfect linear relationship. This would be the perfect R equals negative 1. Do I need to separate you boys back there? Okay, this one, it's not a perfect relationship. It is a positive. They are fairly close together. So that one would be like an R of about 0.9. It's fairly good. This one, it's still positive, but it's getting weaker. They're more spread out. So if you look, that R value is 0.4. So the more spread out they are, the smaller your value. Same thing with the negatives. This one, there's no linear relationship. You would get an R value of 0 there. So if your R is close to 0, that means there is very little relationship there. Okay, even this last one, you're still going to get an R of 0. There is definitely a pattern there, but R measures the linear relationship. So it doesn't tell us if there's like a quadratic or something like that. So if it's not a linear relationship, you are going to get a very small R value.
So, like, they can never be greater than 1.
Right. It'll always be between 1 and negative 1. So we are going to do one by hand, just so we can appreciate that. And then we will probably use the calculator for future ones. I am going to help us along, why don't we use our calculator to find the mean and standard deviation for these things? So go to your calculator, go to your stat, edit, and we are just going to go ahead and enter both of these. So clear out everything that's there. So I'm gonna put my X's in my L1.
Well, this one's already not linear because you have 3 values.
It's not a perfect linear, no. So we know we're not gonna get a 1. Okay. Does everybody have those points entered? You can go to stat, calculate. We usually go to 1 variable statistics, but I have 2 variables entered. So I'm going to go to 2 variable statistics, number 2. Just enter through.
I'm gonna give you all those.
Should. Did yours?
Yeah. And then if we were just doing this, we would just do each one by hand, like find the standard deviation.
Yes, and we know how to do them by hand. Okay. So I can see my X bar is 4. My sample standard deviation for X is my 2.4495. So X bar. Y bar, if you keep scrolling down, that is 10. And the standard deviation for Y. 125. Okay. We need to calculate. If you look at that formula on your formula sheet or on the box, we're finding that R. We have to do X minus X bar over the standard deviation of X. We need to do that for both the X and the Y. And then we're going to have to multiply these things. Okay. If you need to, you know, if you wanted to list like these ordered pairs out to the side, you're welcome to do that to kind of distinguish your rows. Okay. So for each value, you're going to type your X value. So for the first one, I'm going to do parentheses. 1 minus my X bar, which is 4. Close my parentheses, divided by the standard deviation, 2.4495.
How many decimal points do you use?
Let's do 4. I get negative 1.2247. So we are going to go down the list and do this with all the X's. And I think if you have it entered, you can hit second enter and just bring it back up and change your X value. So the next one, my X is at 3. And I have that twice. I have a 6. Does everybody know how I'm calculating these values? I'm doing the X value minus the mean of X divided by standard deviation of X. So for my Y's, I'm going to do my Y value. So for the first one, that would be 18 minus the mean of Y, which is 10, divided by the standard deviation of Y, 5.6125. Once you get those for the correlation coefficient, we have to multiply. So I am taking my x times my y. It is a lot of numbers. We thought standard deviation was long. Is everybody with me how I'm calculating this? So remember, we are looking at this correlation coefficient. We have done this, the product part. What does this formula mean? So we're going to add them all together and divide by n minus 1. Yes, it's very similar. Divide by n minus 1. We had 5 points, so n minus 1 would be 4. And I get my r to equal a negative 8. The number of ordered pairs we had. I get my r to be negative 0.9456. So that means there is a fairly strong negative relationship here. Remember, negative 1 would be a perfect negative relationship, so negative 0.94 is a pretty good one. Now, wouldn't it be nice if we didn't have to do this every time? Okay, we could. It's a formula, multiplying, dividing, adding, I mean, stuff we could do, but it's very time consuming. So, on your calculator, what I need you to do first, you should not have to do this every time, but if the memory ever gets reset on your calculator, you will have to go in and do this. You need to hit second and 0. We need to go to diagnostics. So I think it brings up, you should be able to hit like a D, which is, I don't even know which one, over here. Or just scroll down. You need to find diagnostics on. So just scroll through. It won't stop. So go down. There's a diagnostic on, off, and right below it is diagnostic on. Hit enter when you get to your diagnostic on. And hit enter one more time, and it will tell you done. Okay, so if you ever try to do this and it doesn't come up, okay. Now,
What do I do now?
you had the diagnostic off, the cover stuff there now. If we go into our stat, calculate, I want you to go to number 4, linear regression, AX plus B. And hit enter through all this stuff. if your diagnostic wasn't on, all it would tell you would be the A and the B. Because we turned it on, we have this R and R squared. What do you notice about R?
It's the same as our
It is what we got. So it's negative 0.9456, which is the same thing we got by hand.
8.9.
So you can do this on your calculator, like the other stuff, standard deviation. I might ask you to do one by hand, but you can use the calculator after that. All right?
What's the R2?
We will talk about that next week. So we need to be able to test for a linear relation. We have this correlation coefficient, and we are going to spend today and next week trying to decide what's significant and what's not. Grab your formula packet, please. If you go like the back of the second page, there are some tables here. Right in the middle is table 2. We are going to use this to decide what is a significant critical value. You know, we can agree that R of 0.9, that's a pretty good linear relation, that's probably significant. But is R of 0.5 significant or not? So we need to be able to decide that. You'll notice in this table everything is positive. So what we will do is find the absolute value of our correlation coefficient, absolute value of R. Then we will compare it to the table. And if the absolute value is greater, we say that there is a linear relation. So for our example, in example 3, we got our R to be negative 0.9456. So the absolute value of R would be positive 0.9456. Then you're going to go to table 2. We had how many data points in our example? 5. So you are going to go to where n equals 5 on table 2. And it tells you that our critical value is 0.878. So as long as, so that means in this example, to be significant, R would have to be bigger than this critical value. So is our R significant? Yes. As long as it's bigger than the critical value, then it is a significant linear relation. So we can say yes. There is, was it a positive or a negative linear relation?
Negative.
Why do we know the negative?
Not a negative sign.
Right. The original R was negative. And it's because my R, the absolute value R, is greater than the critical value. That's what told us yes. If it wasn't, then we would not be able to confirm that it was a linear relationship. Okay. All right. Last thing I want you to touch on are just definitions. Are you trying to?
No, just look at it.
You're welcome. I just wanted to touch on what a lurking variable is. So the lurking variable is something that's related to both the explanatory and response variable, but maybe you weren't looking at to begin with. For example, ice cream sales and crime rates actually have a very high correlation. So does that mean that we should shut down the ice cream shops to help our crime rates?
Correlation is not causation. What? Correlation is not causation.
Just because there's a relationship doesn't mean one's causing the other. Is there something that might be causing both things? When do you eat a lot of ice cream? When you're sad?
And I'm really sad there's so many crimes, so maybe they should stop having crimes.
Or another option, so it could be, sadness.
It's hot outside.
It's hot outside. When it gets hot,
People get restless.
crime rates go
People
up.
are like,
When it gets hot, people also eat more ice cream. Does that mean that the people eating the ice cream are going to get their ice cream cone and then going and robbing somebody?
You never know. We just
Not
have different ways
necessarily.
of dealing with our problems. Right, some people eat ice cream, some people rob banks.
So you just have to be cautious. Just because two things are related doesn't mean one is causing the other. This example was talking about the number of sodas drank a week and bone density. And if we look at this, it looks like as you drink more sodas a week, what's happening to your bone density? Yeah. So does that mean drinking soda decreases your bone density?
No, but I mean it can.
Maybe it does. We don't know that it doesn't, but could it be something else?
Maybe they only drank soda and didn't eat anything else.
Okay, so maybe it's their overall diet. Maybe it's not necessarily the fact that they were drinking soda, but it was the fact that they weren't also drinking milk along with it. Or maybe it was the overall health of the people in the study.
Maybe
Just because
don't.
there is a relationship doesn't mean one causes the other. Correlation does not mean causation. Okay. Any questions for me?
So what was the looking variance?
On the other one?
Yeah.
Heat. I mean, that's what I thought of, but it could also be emotional state. I mean, okay.
We're all just so sad. Rob makes me ice cream.
Guess you have to eat ice cream to celebrate after you do something. Or
Right.
you got away with it, go get your
I
ice
just
cream.
got so much money, let's go rob a bank. Let's go eat some ice cream. Dude, let's just